This video will cover adding rational numbers, and what I mean by rational numbers are fractions and decimals. So if you want to write in your notes adding fractions and decimals, that's fine, but they will be positive and negative to make it a little more interesting, okay? Now, here I say to add fractions, you need a common denominator. In other words, the number down on the bottom, which is the denominator, needs to be the same. These are not, so we need to get one in common. So you look and say, what will both of those numbers go into? Now, it's always nice if you have one that goes into the other, but here it's not the case. I'm going for the least common denominator, which in this case would be 12. And what you do then is you put parentheses around your fractions. Say, all right, what do I have to multiply this 3 by in order to get 12? And I said I'd multiply it by 4. Whatever I multiply the bottom by, I multiply the top by. Now here's how it works. 4 over 4 is equal to 1 whole. And 1 times anything doesn't actually change its value. It's going to change the way that fraction looks, but it's still going to represent the same number. So on the other side, what would I multiply 4 by to get 12? And it would be 3. I would do that on the top and the bottom. Numerator times numerator, so 4 times 2 is 8, over denominator times denominator, 4 times 3 is 12, plus 3 times 1 is 3, over 3 times 4, which is 12. Now, the denominators are the same, so I can add the numerators. Here I have 8 plus 3 gives me 11, and I keep the denominator. If I can simplify the fraction, I will, but I cannot. 11/12 is the answer. Now, that's great. Let's make it a little more interesting. Here, when you have mixed numbers, which is what we have here, I suggest you make them improper first. You don't have to, but there will come a point or certain operations where you have to. So why not just do it for all of them? It just makes sense to me anyway. Now, notice that this first one is negative. Uh-oh, that really throws things off, doesn't it? No, not really. This is what you want to do. You want to ignore the you don't have to write this down. Ignore the negative for now, okay? The directions here say make them improper. So I'm going to pretend that negative isn't there. I'm kind of covering it with my finger, even though you can't see my finger there. And then I'm going to make this improper. Remember that the way that you do that is you take the denominator times the number out in front. 3 times 8 is 24. And then you add it to the numerator. So 3 times 8 is 24, plus 1 is 25 over 8. Do the same thing with the other one. 4 times 5 is 20, plus 1 is 21 over 4. Now, don't forget to write the negative down here, okay? You're ignoring it right now, but you don't want to forget to write it, because what will happen is you'll get further down in your work and you'll forget that one was negative, and that impacts the whole problem. All right, now we need a common denominator. It's nice because the least common denominator between these two is 8. So I only have to change this one fraction. I'm going to multiply by 2 over 2. 2 times 21 is 42 over 2 times 4, which is 8. Plus this first one, a negative 25 over 8. Now, this is when the negative has to be used. We have a common denominator, so we're ready to do the math on the top. So look at this as a negative 25 plus 42. Our rules say, well, the signs are different, so you subtract the numbers. I'm going to subtract the numbers. 25 minus 42. Now I can't do this subtraction. I'm going to borrow from the 4. That becomes a 3. This is 12. 12 minus 5 is 7. 3 minus 2 is 1. I have 17. And then you say take the sign of the number with a greater absolute value, or the bigger number. The bigger number here is positive. So it's going to be a positive 17 over 8. We do not want to leave this improper. We want to make it into a mixed number. So we say 8 goes into 17 2 times. 2 times 8 is 16. So that means we have 1 left over from that 17, and we keep the denominator the same. So it's 2 and 1/8. Okay? All right. let's move on to some decimals. To add the decimals, you need to line up the decimals and fill in the blank spaces with zeros. Now, here on this first problem, again, we have one that's negative. Great. Not a big deal though, okay? We want to put the larger number on top. So here, bigger number on top. That does not mean the one with the most digits. It's actually the larger number. So remember, when we're comparing numbers, we look digit by digit when it's decimals. A 1 is bigger than 0, so this is the bigger number. I'll put 1.8 here. We need to line up the decimals, 0.05, and fill in the blank spaces with 0. There's a blank space here. This is where doing neat work is extremely important, because if your columns are off a little bit, you might not realize that a 0 is supposed to go up there. Now we can look back at the signs. We have different signs. One is negative, one is positive. So that means we have to subtract these two numbers. I cannot do 0 minus 5, so I'm going to borrow from the 8. This is 10 minus 5 now, which is 5. 7 minus 0 is 7. The decimal goes straight down. 1 minus 0 is 1. Look back up in the original problem, and again, what's the bigger number? And it was this one. That's negative, so my answer is negative. Go back to those integer rules if you've forgotten how to do this. For the next one, the bigger number on top. Go ahead and try this problem on your own, okay? Pause the video and try it. Did you actually pause the video? I hope you did. All right, if you did, you would hopefully realize that 2.04 is a larger number than 1 point something, okay? I'm going to line up the decimals, 1.809, oops, 8093, and I'm going to fill in the blank spaces with zeros. Now, these are both negative, so I have a negative here and a negative here. My rules say if the signs are the same, you add the numbers. So I'm going to add them. This is 3, 9, 4, 8, decimal straight down. 2 plus 1 is 3. The signs are the same. Add the numbers, keep the sign. That's what the rule says. Okay? And there's our answer. Now, let's make it a little bit more interesting. Here, look at that. Isn't that beautiful? I love it. If you have decimals and fractions in the same problem, which you will, you need to convert them to either all decimals or all fractions. It's just a matter of what you prefer, okay? Most students prefer decimals because they don't like the whole common denominator thing. Hey, whatever, man. Now, this one is really easy, okay? 2.5 is just 2.5. If it was a harder mixed number, you'd make it improper first, and then you would divide numerator by denominator. You can get the decimal. Or you could just put the 2 out in front and figure out what a half would be. But this is an easy one. It's 2.5. I'm converting it all to decimals because I'm assuming, that's what most students want. That's what I've seen over the years. Most students are like, I don't like fractions. I'm going to take 1/5 and I'm going to convert it. 1 divided by 5. Remember how to do this? The first number, top numerator is in the house. 5 cannot go into 1. So I'm going to add a decimal and bring it straight up, yo. Now, it can't go into 1, so I'll put a 0. I'm going to put a 0 here. 5 can go into 10 2 times. 2 times 5 is 10. Subtract, there's no remainder, so I'm done. So this is plus 0.2. Now, we just have to add them all together. Simple, right? I think so. So we have 2.5 plus 0.25 plus 0.2. I'm going to fill in the blank spaces with zeros. Add them. This becomes 5. This becomes 9. Decimal straight down. 2. So it's 2.95. Now, that was interesting, but it wasn't really interesting. Let me change it ever so slightly. 2.5, and this time we say plus a negative 0.25, plus 1/5. Now, the nice thing about this one is that we already know what the decimal equivalents are, so we can just go ahead and write that. So I have 2.5 plus a negative 0.25 plus 0.2. Now I can't just take all of these this time and line them up like I did over here. That won't work because the first two I'm actually going to have to subtract because this one's positive and that one's negative. So I'm going to do that first. Now remember our good old rule that says we can, because it's all addition, we can move it around and add it in any order? You guys remember what that rule is? To move around is the commutative property. We can actually take this 0.2 and add it to this and make it 2.7 and then do our subtraction. But that would be too easy. Let's just say you forgot that rule, because you probably did, and you're going to do it the harder way. The harder way is to say, all right, I have 2.5. I'm putting a bigger number on top. And then I'm going to put 0.25 down on the bottom. Fill in the blank with 0. And then I'm going to subtract them because they have different signs. I cannot do 0 minus 5, so I'm going to borrow from this and make it a 4. That's 10. 10 minus 5 is 5. 4 minus 2 is 2. Decimal straight down. 2 minus 0 is 2. Step 1. Almost done. What sign is it? Positive or negative? Hopefully you said positive, and if you did, you are correct. So this goes here. Now we have 2.25 plus a 0.2. The signs are the same, so we're going to add those. So I have 2.25, and I'm going to line up my decimal, 0.2. Fill in the blank with 0. Plus, this becomes 5, 4, decimal straight down, and it's 2. 2.45 would be the answer. Okay? Pretty cool? Yeah, I think it's pretty cool. I'll see you later.